Okay, power is a measure of the rate at which work is being done. If 1 joule of work is done in 1 second, so the rate of working is, we call it as a watt. Okay, hence, a machine that does 1000 joules of work per second is working at a rate of 1000 watts or 1 kilowatt. We look at example 17. Each of the diagram below show a particle moving along a straight wire under the action of the constant force. In each case, the particle travels the length of the wire in 5 seconds. Okay, so find the work done by the force and the average rate at which the force is working in each case. So if you still remember, how do you want to find the work done? Is the force time the distance. So simply a way it is 6 times 10 is 60 joule. Okay, so this is the work done by the force. So what is the average rate? Average rate of working. Okay, so rate of working would be 60, the work done, divide with how many seconds? So 5 seconds. So your answer is 12 watt. Okay, if let's say for question B, you have an angle. Okay, the same as before, we need to find the work done is the force times the distance. So if let's say you have a angle here, so you have to use cosine 60, okay, and then times with 8 meter. So your answer would be 200 joules. So what is the average rate of working? So you divide by how many seconds? Should be 5. So the answer is 40. Okay, example 18. Okay, find the rate at which work is being done when a mass of 20 kg is lifted vertically at a constant speed of 5 meters per second. So we know that the work done, because it is moved vertically and is raised up, lifted up. So there is an increase in the potential energy. So we will use mgh, where 20, 9.81, and then 5. So we get average approximate 980, yeah? Because in this book we use 9.8 instead of 9.81. Okay, how do we find the rate of working? The rate of working, because it is done, the question is in meter per second. Okay, it means it is per second. So your answer, the rate is also the same value, which is 980, because you divide by 1 second. Okay, and then for example 19, a pump ejects 12,000 kg of water at a speed of 4 meters per second in 40 seconds. Find the average rate at which the pump is working. So since this is, you have to determine whether you want to use, whether the person have to use mgh or the kinetic energy. So for this question, we have to consider the kinetic energy. So it is half mv square. So we have half 12,000, and then 4 square joules. And then if you want to find the rate of working, you have to divide with the how many seconds. So this one is over 40. So you just divide this one 4 square. You have to divide by 40. So your answer is 2400 joules in 1 second, or 2.4 kilo. Sorry, this is kilowatt. So this is watt. So this is your answer. And then for example 20, a constant force acts on a particle as it moves along a straight wire from point A, position vector I minus jm, to point B. Okay, first, for any information, you can draw the axis to visualize what information is given. In this question, we have 2 points, which is point A and B. Okay, first, point A is a position vector. This is point A. So we have 1, 2, and then 1. So this would be A. And then we have B, negative 1, 1, 2, 3. So we have B here. So this is the straight line. So this will act as the distance. So the work done is force times with the distance. So we already have the force, which is negative 2, 1. Okay, now we need to find AB. Okay, AB means your position vector B minus A. So this is B, right? Okay, so we have negative 1 minus 2, 3 minus 1. So we get negative 3 and then 4. So this one would be negative 3 and 4. So the work done is negative 6. 6 plus 4. We have 10 joules. Okay, what is the rate of working? We divide by the second. How many seconds? So in 4 seconds, so divide by 4. So your answer is 2.5. The answer in the book is incorrect. So you need to, it's instead of 4, the answer